Okay. Yeah, today we will begin today's journal club. Can you hear me? Okay. Hi. Today's paper is Lacey ATL 2020. Lacey, I don't know correct pronunciation with the name, but yeah, the paper about the sound symbolism paper. So the presenter is Moe Okuma-san. Yeah, if you prepared, if you're ready, please go ahead.
Okay,
Sorry, yeah.
could you allow?
Okay, now you can share your presentation. Please try. Does it work? Okay, yeah, please go ahead.
Can I can I share the slide now?
Yes, I can see your slide, but it seems like your
Yeah, presenter notes is presented.
we can see the
Yeah.
presenter mode version of your display.
Exchange the display. You can see. Yeah, that's Borland. Okay.
Yeah.
This one. Is this better?
No, it's good.
Oh, okay. Sorry, but thank you for attending and giving the chance. Today, I will this paper and I'd like to speak background. Firstly, sound symbolism refer to the meaningful relationship between all words, sound, and its meaning. For example, said words like maluma are often associated with round shapes, while tagete is linked to sharp shapes. However, the specific acoustic features that influence this association remain unclear. So this study was designed to uh, address this gap. And the research objective is that the research aim to identify which acoustic parameters are responsible for the sound symbolic mapping between sounds and shapes. The researchers used perceptual evaluations of roundness and sharpness for both auditory visuals and visual shapes, comparing their operative uses well representational similarity analysis, so RSA. Say is originally used to study brain activity. In functional magnetics resonance imaging, fMRI, RSA assesses spatial patterns of brain activity to different stimuli, assuming that similar stimuli produce similar activity patterns. RSA compare the the similarity between stimuli by calculating the pairwise correlations of their features. So in this study, RSA is applied to the analysis of perceptual similarity between pseudowords and shapes. Our next topic is materials and method. They prepared 537 pseudowords and 90 visual shapes. And then RSA has 4 steps. Step 1 is perceptual ratings for reference RDMs. And step 2, create reference RDMs and compare close modality. Next, step 3, compare reference RDMs to parameter RDMs within modality. Last step is 4, compare selected parameter RDMs cross-modally. And then there are acoustic parameters and visual parameters. So acoustic parameters include phonemic content and aspects of the vocal characters. And which were the distribution of both amplitude and frequency over time, and acoustic periodicity in the speech waveform, and the regularity of voicing or voice. While visual parameters and notes are indices of a global shape, whereas the acoustic parameters reflected specific acoustic aspects. Then participants rated either pseudowords or shapes using one of 2 7-point Likert type scales, such as roundness, pointedness from 1 to 7. The left panel shows the examination of the RDMs for the perceptual ratings of the pseudowords and shapes, such as that roundness, pointedness rating for the pseudowords were relatively graded. And while right panel shows participants largely rated the shapes as either highly rounded or highly pointed, with few shapes considered intermediate. About results of comparison of auditory perceptual ratings to acoustic parameters of pseudowords were related to the auditory perceptual ratings, roundness, pointedness. They computed the second order correlation between the RDM for auditory perceptual ratings, and that for each of the correlation, the correction for multiple comparisons, there were significant positive correlation for spectral tilt is B, and Temporal FFT is C, and speech envelope is D. The remaining acoustic parameters were uncorrelated. Our last results comparison of visual perceptual ratings to visual shapes parameters. They carried out within model second-order correlations between the RDMs of the visual ratings of roundness, pointedness, and the, for each visual parameter of the shapes. After correction for multiple comparisons, there were significant positive correlations. For the SMC B and it's C silhouette, and it's the image outlines, and last one is the car distance, but not for the spatial FFT. The discussion part is has three parts. First one is cross-modal relationship. The audience for acoustic spectral was significantly correlated with the RDMs for the visual SMC, so image silhouette and image outlines. The RDMs for the acoustic temporal FFT and the visual SMC were also correlated. And they said as further works to the first one is to confirm that the auditory spectral parameters and global indices of visual shapes, not the spatial frequency spectrum of visual shapes under Vincent symbolic cross modal correspondence. Second one is to examine why these cross modal relationships are fairly weak. Discussion part 2 is relationship between acoustic parameters and pseudowords ratings. So they set spectral tilt, the temporal FFT, and the speech envelope were all related to roundness, pointedness ratings, as demonstrated using RSA. I made the below part is 結果の予測 but maybe we don't have enough time, so sorry, but let me skip this part. And next discussion is relationship between visual parameters and shape ratings. So RSA showed that the simple matching coefficient, so SMC, image silhouette, image outlines, and Jacal distance were related to perception of the shapes as rounded or pointed. Oh. Novelty comparative to previous studies. So previous studies examined how acoustic and visual parameters contribute to sound to shape mapping separately. But this study, the number of pseudowords used in this study and the sampling of the potential phonic space is much more comprehensive than earlier studies. And they also said the use of RSA allows very different stimulus sets and physical parameters to be compared on an equal footing. And comparison based on their pairwise dissimilarity. So its conclusion, so one is the auditory and visual ratings were in keeping with the cross-modal correspondence between auditory pseudowords and visual shapes. And number two is global acoustic measures of the pseudowords. The speech envelope and the spectral measures were related to the auditory ratings. Third one is multiple global indices of visual shape were related to the visual ratings. Last one is the acoustic spectral measures were cross-modally related to the global indices of visual shape. Conclusion and can I keep my can I say keep saying a list of things that were difficult to understand?
Yeah, I think you can carry on. Yeah.
Thank you. This difficulty point is maybe a nervous point, but I'd like to share them. First one is there is a difference between using. Oh, I missed. But GWOT and RSA. So they said advantage of RSA. RSA allows the comparison of parameters that involve multiple measurement samples of pseudowords. Is that same? GWOT and between GWOT and RSA? And they also said compares each item to every other item as opposite to conventional relational analysis that treat items as a group. So then a potential drawback of RSA for parameters expressed as a single value per item, items must be binned into sets, resulting in a loss of sensitivity. So voice quality measures were not found to be related to the auditory ratings using RSA. So and my other question is, what are the weak points of GWOT? Sorry, it's not related this paper, but just another question. Second one is a voice that is not produced by a human supplied variable. They the the they said the supposed of projection in this paper measures of voice quality were correlated with perceptual ratings because the speaker who recorded the pseudowords pronounced them differently according to her or his their expectations of their roundness or pointedness. So they said this. They said about this the supposed objection or the the speaker's effort to speak with neutral intonation and hardness to consciously modulate complex parameters such as simmer or mean HNR. Then I would like to say, I just want to say, how about machine or AI voice about the supposed objection? The third one is, can we find out to what extent language is an influence? But is it a bad idea to find out? They said in the paper, non-linguistic cross-modal correspondences might be a good source of predictions about some symbolic mapping for pseudowords. Like they could expect pseudowords reflecting the brightness, darkness, diminution to be modulated by their amplitude and or pitch. It seems it seems it is it seems my question my wonder is jumping from this this topic, but yeah, I also have this question. Oh, sorry, it's still Japanese, but so yeah, it it stopped my I will stop this.
Okay.
Yeah.
Do you have anything to say? Anything you want to say in my presentation?
Do I have enough time to speak more?
Okay. Yeah. Thanks. So yeah, we have 10 minutes or 10 minutes and to discuss. Do you have any comment on questions or about the presentation? Including Okuma-san's question in the last slide. Yeah, one point in Okuma-san's last slide, weak point of G-Watch. Yeah. I don't know so the details of algorithm of G-Watch, but in my very limited experience using G-Watch, yeah, G-Watch success rate in G-Watch varies very binary, tends to be binary. Yeah, sometimes they succeed alignment perfectly, and sometimes failed perfectly, very binary. But RSA is basically is a correlation that it changes continuously. Yeah, so I think this is very difference between RSA analysis and G-word analysis. Yeah, but yes, yeah, my experience of using G-word is very limited, so it's not. I don't confident it is a very consistent. Yeah.
Okay. Thank you. Yeah.
But another interesting point in this. Sorry, Ito-san, please go ahead.
Thank you. Thank you for your presentation, Okuma-san. And thank you for organizing this, Saji-san. And thank you, Asano-san, for sharing this paper with us. Regarding the binariness of GWOT, in this paper, the qualia of the visual shapes were rather binary.
Yeah.
The auditory qualia was more smoothly distributed. But they do not really discuss on that issue, but they just calculate the correlation and say that they were correlated. That is true, but I think there's a qualitative or very important difference that is expressed there in the results, and I thought about that, why they might be different, and how we can evaluate and quantify that difference, and then we can have a deeper understanding of it. That was what I thought about this. Can I share my slide? I have two like short slides that I prepared for you. Let me see. Can you see this?
Yes.
Okay. So we have a roundedness or pointedness qualia for sound, and we also have roundedness and pointedness qualia for shape. And my question is whether these qualia can be considered the same. The qualia itself is very hard to describe verbally, but we only have limited vocabulary to describe those qualia, and so there is probably always a mismatch between the real richness of qualia and what the words imply. So in this case, so that is why we have this very different dissimilarity matrices in these results. So it would be interesting if we could evaluate not the similarity, but the dissimilarity of the dissimilarity matrices. They just simply calculated the correlation coefficient, Spearman's correlation, for evaluating the similarity of the matrices. But I asked my ChatGPT, and he answered that he provided me with other measures of calculating the similarities of RDMs, which are shown here. Maybe we have other options for studying the similarity and dissimilarity of matrices. And I have one hypothesis regarding the binariness of the RDM for the visual shapes. I think it might be because the words roundedness and pointedness are originally for describing visual properties. Those words are native to describing shapes, and those words were borrowed to describe the sound qualia. So there's inherently a mismatch, or that is where the smoothness of the boundary is introduced, maybe. So if we have descriptors that are more native to sounds and use those words to describe qualia of other modalities, then the RDM for the sound might be more squared and binary-like, and the RDM for describing other modalities might become more smooth and boundaryless. That is what I thought when I read this paper. I appreciate your opinion on this.
Yes, I do agree with you. Yes. I really think that we need to have some language to describe the quality of the auditory stimuli. So yeah, I don't have any good idea for measuring the qualia, a sound qualia, especially the smoothness and rough, like abruptness or something. But yeah, so I don't have any good solution for now, but I think one of the problem, or one of the topic we really need to think about is about this paper is that the measure of the auditory stimuli, I mean the roundedness or spikiness is not very does not match the auditory stimuli well. It's not very suitable measure. Yes.
I'm curious that is it a well-known feature that shapes have binary features? Other studies claim that kind of claims. Do you know any studies which claims they are shapes parameters of shapes that could tend to vary binary?
No, I do not. It's just a guess. But in their distribution, they're binarily distributed. But the reason might be because of their choice of the shapes. They were very limited in the variations when I saw the original figures. Maybe if we use a more varied and various different shapes, those matrices would probably be more
non-binary.
Yes.
Yeah.
But in this case, I don't know. But what I said was just a guess. Yes.
Yeah. But reasonable. Yes, it is reasonable. Okay. Oh, any comments and questions?
You mean regarding Okuma-san's questions?
Yeah, so or in general.
Or comments in general.
Paper.
Yeah.
I have we can have one question.
One question.
Time. Yeah. Do you have any question, comments?
Well, can I have one more question?
Yeah.
Okay. Okuma-san mostly focused on the physical parameters that determine the qualia in vision and audition. That was my motivation for reading this paper at first, but I had another question to ask, which I showed you earlier. But I was also interested in how different acoustic features determine the quality of sounds. Mostly because I've always been interested in the stimulus parameters determine the tone color or timbre of sounds. The not only verbal sounds, but instrumental sounds also have pointedness or roundedness or denseness or narrowness and broadness and all those kinds of rich qualia. And having always wondered why those sounds have such visual-based qualia. So maybe we could use this type of analysis technique to study the physical basis of timbre in music.
Perhaps the spectral tilt might be the candidate
Yes.
to, yeah. Yeah, I think it's very interesting. When I thought it's interesting to read this paper, Lacey's paper, that spectral tilt matters. And so then I also think that the spectral tilt can be applied to the analysis of musical sounds. Yeah, then perhaps we can connect what we know about linguistic sounds and what we know about musical sounds. Yeah, that would be an interesting investigation.
Okay, now 35 minutes over 35 minutes. Yeah. Okay, today's journal club is that's all. Thanks for participating in the journal club. Okay, I will recording stop.